So I'm very pleased to be able to introduce our scalability panel. So we've got Brian, who will be moderating, not Jeremy, from the Risc side. Orest from Scroll, Brendan from Polygon, Jeremy from Risc, and Ujval from the Specular team. Brian, I'll hand over to you.
Yeah, thank you. So I'm going to let each panelist introduce themselves, talk a bit about their project, and explain, what it has to do with scalability. So you, Orest?
Yeah, hello. This is Orest. I'm an infrastructure engineer at Scroll. And at Scroll, we have embarked on this mission to scale Ethereum using a very boring developer experience. As in, we are trying to create a so-called ZK EVM type 2.5, if anyone's been following along on Vitalik's blog. That wrongly classifies us as type 2, by the way. We are actually type 2.5. But what that means for you as a developer is that you'd be able to literally take the bytecode that was compiled for the EVM and put it on such a rollup, on Scroll's ZK EVM. And it would just run. And so to that goal, of course, this big roadblocks, things are complicated when it comes to setting up the circuits. Things are very demanding when it comes to getting the talent to be running this. And also proving such, creating such ZK proofs is actually computationally very expensive. But we still believe that this is the trade-off to be making, as in to take advantage of the critical mass of Ethereum.
Cool. Brendan?
Hey everyone, I'm Brendan. I work on ZK R&D and our ZK EVM at Polygon. So yeah, we focus on building faster proving systems. So we built Plonky 2 and Starkey. And then, like Orest, also building a ZK VM where you can take existing code on Ethereum and deploy it and use existing dev tools and infrastructure. And so that's about it.
Cool. Jeremy?
Hi, I'm Jeremy from Risc. And at Risc, we're basically working to help sort of expand the realm of people who can do zero-knowledge proofs. We have a zero-knowledge proof system that allows you to run arbitrary code in Rust and also eventually C++ and Go inside of a zero-knowledge proof. So above and beyond sort of just the ZK EVM, we're sort of a more general purpose ZK VM. And sort of our current goal is to also provide a proving market, which we're calling Bonsai, which is basically allows you to have those proofs proven and placed onto any number of blockchains. Of course, Ethereum obviously is our sort of initial focus for that work.
Cool. And then is it Ujval?
Yeah, you got it. So I'm Ujval. I'm a PhD student at Berkeley. I'm currently working on a project called Specular, which is an EVM native and EVM equivalent optimistic rollup, one of the newer ones out there, and we try to address some of the security and decentralization issues in existing optimistic rollups today, such as like Optimism and Arbitrum.
Cool. A little bit of feedback there.
I think it helps to be closer.
Me too.
Yeah. Cool. So, we're trying to talk about scalability and centralization and how all these things are connected. So I'm curious, just a quick survey. What do you think the biggest gap in scalability ecosystem-wide is right now?
The biggest gap, there's so many. And we could start from the non-technical ones, such as terrible UX, what has been talked about just before, which is an overarching things and which makes it such that it's actually harder for developers to join the crypto world in the first place, which makes scaling slower. But we could also go into the detail and think about, okay, assuming we have the manpower, what would be a bottleneck? And I think right now it's actually, surprisingly enough, not the ZK circuits themselves, but there's a lot of engineering and infrastructure engineering, in fact, and good old engineering challenges of setting up systems that can withhold large traffic and I/O, that is actually holding us back a lot as well.
Interesting. Brendan?
I would actually echo that. I think that there's this misconception, especially for ZKL2s, that they're somehow bottlenecked by proving. And this actually isn't the case. So I think that there's an understanding gap for scalability, because the bottleneck, like for Polygon, is actually in the sequencer. Like you can think of it as on a zkL2, like we have to execute all of these transactions that touch shared state in serial before we can even start generating a proof. And it's really difficult actually to parallelize that. Whereas with proving, like we can very easily parallelize generating a proof for each transaction or generating a proof for sort of like a part of a transaction. And so I think that like there's this misunderstanding that ZK tech is sort of holding us back, when it's actually like a much more boring problem that's existed like sort of since the beginning of Ethereum and blockchains.
Yeah, I would agree that serialized execution certainly creates a lot of difficulties. And actually I think that and I would also add that another big issue that is also not ZK related specifically is that with like ZK, you can take effectively an arbitrarily large amount of computation and prove its correctness and get it down to something that's very small. But state updates still need to be recorded somewhere, right? And those still need to be, decentralized in a way where the data availability is still safe. I think there's a lot of open problems in terms of these questions of, okay, so now that ZK might allow us to solve the problem of how do you actually do the computations in a scalable enough way, now how do you do the transaction sequencing, how do you do the storage and data availability, all of those kinds of things in a way that lets you build an overall ecosystem that allows real parallelism. And I think part of it might end up requiring people to, currently Ethereum has this very notion that all the transactions are fully serialized relative to each other and everyone gets to see the entire state of the world. And I think that is going to have to shift if we're really going to be able to actually truly get scale at some point.
Yeah, I agree with most of that as well. I think data availability is definitely a big issue, both across like ZK rollups and optimistic rollups. And I think there's been a lot of work in the community, particularly at L1, to improve the cost of data availability. There's I think like EIP 84844, is that it? Yeah, and there's a ton of work going on in the sharding space for Ethereum. So yeah, I would say data availability. I think like people have mentioned proving costs. They're not necessarily the bottleneck, but of course you want to get those costs as low as possible, so anyone can participate in these prover networks. So there's some work on getting proving time down, particularly for using linear time provers. There's been some work in our lab doing that, but I guess these guys can talk more about the ZK side than I can.
Cool. Well, before we get into how decentralization and scalability are connected to each other, maybe people could briefly state. I mean, it seems to me like there's not as much care for or about decentralization as it's kind of like privacy. We're like, yeah, privacy is really important, and then at the end of the day, how many users actually care about it? So what's the most salient, just one reason people should care about decentralization?
Because FTX.
I think building systems that are resistant to adversarial regulators is actually a really important part of building decentralization, especially in L2s. There's not a security advantage. An L2 doesn't depend on decentralization for security, except insofar as it can be halted or a regulator could take action. So.
Yeah, I mean, I think it's interesting because as you look at ZK, you can actually start to separate the question of verifiability versus the inability to censor transactions, censorship resistance effectively. If you look at, say, one could run a bunch of zero-knowledge proofs on AWS and present those to people, and what that does is that means that you couldn't be running incorrect code, right? Obviously, if I just have some AWS service now, you have no idea whether I'm doing what I'm saying I'm doing. With zero-knowledge proofs, you can verify that I'm doing it correctly. But without decentralization,
can you?
that central component can just not do certain transactions if they don't feel like it. They can affect front-run markets, all kinds of things like that. So I think decentralization is mostly important for that. And I do think zero-knowledge helps give you a bunch of other options for decentralization. One of the interesting things to me is that I can let some random person, if I'm talking about public data, I can let some random person do a zero-knowledge proof, and then I can use that proof in a network, unlike a lot of systems where you can't let random people do work for you without duplicating their work. In zero-knowledge, you can. So I think that allows options.
Yeah.
I think there's a misconception, actually, if I may interrupt.
Oh, go ahead.
And
Yeah,
that is, I think it's actually very, very few people who are able to actually trust your ZKP because they need to understand what you're proving in the first place. It's a similar problem to the one you deem as solved by a ZKP in the first place.
Well, so I think there's this question, we get this a lot actually, because people misconstrue zero-knowledge proofs with like formal proofs or verified correct code, right? We recently had a person who was like, well, I wrote this bug in my, code, and your zero-knowledge proof system doesn't stop this bug from happening.
Yeah, right.
I'm like, well,
Exactly.
that is correct.
Yeah.
And I think that one thing that the industry will need to deal with at some point is figuring out mechanisms for basically repositories of known safe code or different kinds of stamps that things have been audited in this whole kind of process. I think things are very nascent at that level still, and that's also very important. But I do think that that's separate still from concerns about, say, censorship resistance.
And we need more eyeballs for that.
Yes.
Yeah. Ujval, anything to add?
Yeah, I think I agree that like people don't really care until they need to care, and I think like FTX is a good example. Another one is I think it was like MakerDAO recently that had to like implement something potentially due to state actors saying that we have to return this money back to this.
Maybe try to get closer.
Oh yeah, sure. Yeah, I think the echo is. So I think like that is also an issue for rollups where as long as you have upgradability in like the L1 contracts, someone can force you to perform some state transition that isn't something that would have happened otherwise. So that's one of the issues.
Interesting. Yeah, makes sense. Cool. So you're working on various different scalability solutions. As you've been building your solution, like how has decentralization come up in the sort of deliberations around what you're actually building? So I assume you're probably making trade-offs around decentralization. What's come up and how have you dealt with it?
Yeah, sure. So you need to be making trade-offs, of course. Everyone knows the blockchain trilemma. I think we don't need to be ashamed of making trade-offs. And I'm a big fan of actually releasing something that is half-baked. So for instance, a centralized rollup. So that while you bake the other half of the thing, people can already start giving you feedback and maybe start identifying further issues that might actually accelerate the rest of your work. And so the approach we took at Scroll is to start with a decentralized prover network. By that we mean those nodes that are doing the heavy lifting. These are nodes with GPUs and hundreds of gigs of RAM right now, and that they be decentralized, that people be able to get from some sort of centralized instance this task of creating a proof for a batch of blocks of transactions. Then they can do the heavy lifting and send the thing back. And so a big chunk of the value creation or a big chunk of what the incentivization will need to be caring about is already being tested out in the wild. And only then, as a next step, will we be decentralizing the sequencers themselves.
Makes sense?
So we're taking a similar approach where, again, like Orest, you mentioned FTX, and I'd actually push back on that because I think it's really important to understand that like security and the correctness of execution on L2 has nothing to do with decentralization. Like we give a strong guarantee of that everything that is happening on L2 is correct with the zero-knowledge proof. It doesn't rely on decentralization at all, and so we're still able to provide security to users. But as Jeremy said, for censorship resistance, which we do actually really care about, that requires decentralized sequencing. It requires there are intermediate steps to get there where you could force inclusion of transactions from L1. And so we're like incorporating some of those steps on the way to decentralized sequencing on L2, and for proving as well, we have a distributed prover implementation that will eventually become.
Yeah, I would also add that decentralized sequencing is actually a very hard problem, especially if you want to not have that sequencing be the limiting factor in your scalability. So if you want, low volume decentralized sequencing, we sort of know how to do that. That's kind of what makes blockchains cool. If you want to still get the sort of capacity and scalability that you can get with, by doing recursive ZKP rollups, and making that fully decentralized is quite hard. And I think we're also taking the approach of making sure that we have a roadmap and a path that we believe is credible, that will get us to full decentralization, but that's starting with making trade-offs with regard to, centralization. But yeah, I do think it is also, yeah, you're absolutely correct that people do misconstrue decentralization versus correctness, and correctness can be maintained with a centralized system.
Yeah, so one thing I can touch on that hasn't been mentioned is, so particularly in rollups today, especially optimistic rollups, there's this problem where even though you have client diversity at the L1 layer, right, you can use like GET, you can use Aragon, all these different clients, which enhances the resiliency of these networks. That isn't necessarily the case at L2 currently. So for example, with Optimism and Arbitrum, you currently have to use the client that they've prescribed. And that's not as much of a problem in CK rollups, where you're only relying on the correctness of the client for the purpose of liveness, since the verifier is sound, as long as the verifier is sound.
Presumably.
But it's definitely a problem in optimistic rollups where, potentially if there's a bug in one of the clients, that can cause an incorrect state transition. So you ideally want to be able to replicate this kind of client diversity from L1 at L2. And so this is like one of the problems that we're also trying to work on by using like a different fraud-proof system.
Interesting. Maybe we'll start with Brendan for this one. So what do you see as the biggest obstacles for decentralization in your project or across the industry?
Yeah, so I think it's two things. I think it's engineering complexity. I think Jeremy makes a great point that doing high throughput decentralized sequencing is actually very, very difficult, and it's harder than just like slapping Tendermint on a rollup. I think the other problem is this, there's this notion, there's a tension rather between decentralization and cost. Because if you want to have, especially with decentralized proving, if you want to give good guarantees that your proof will be generated on time, you need some like replication at each like node in your sort of recursive aggregation tree. And that introduces additional cost. Like if I have sort of 4 nodes generating the same proof, like I need to compensate them, or the network needs to compensate them in some way in order for them to continue generating those proofs. But that, like we also pass that cost on to the user. And so there's, I think, this calculus about like what user preferences are as far as like decentralized proving and redundancy and liveness, and then transactions.
Yeah, that's really interesting. I think that's going to be a key. It's like it's a point of sophistication that's actually going to be challenging for users to understand, and for all of these projects to figure out how to explain, like, to users which of these kinds of trade-offs are you going to make, because it's kind of like why you even have to think about them. You kind of have to understand the underlying proving system. But sorry, yeah, Jeremy.
Oh no, I was actually going to just echo that point, which is that I think that as we start to develop these new technologies, I do think there's a need to make sure that the users can understand the difference between centralized but with ZK versus what part is being decentralized. Is the proving decentralized? Is the sequencing decentralized? Also, I think I actually was curious to get some of your thoughts as well on sort of where sort of optimistic rollups, which are one way to sort of increase scalability, will interrelate with sort of ZKP methods for increasing scalability, and how all of this gets made into something that the average developer is able to sort of understand which trade-offs exist and how to reason about them, right? I think there's a lot of like detailed technical things that go on that are non-obvious immediately.
Yeah, so to touch on that, I think, so I get asked a lot, like, why are you working on optimistic rollups, like ZK rollups is a feature. I think, like, part of the answer to what you're saying is, I think, like, one reason why you might see optimistic rollups still be used a lot is they're much more simpler to understand, especially by, not just by, like, users, but also, like, developers who don't have the skill set to, like, look at this like heavy cryptographic machinery. So I think like there's a lot you can do to alleviate that on the ZK side. Like you could try to formally verify your systems to give like better, more trustworthiness for these verifiers. But I think like that's something that takes a lot of effort, and like it's not clear like how long that's going to take. It's also not clear whether like these proving systems will continue to evolve. You're going to have like newer and faster provers, which you might want to add to your system to like, so you're not being outcompeted by like some new rollup. And I think if that's the case, then you need to recreate the trust that you've gotten in like the previous system you've implemented. So I think with optimistic rollup,
No, go ahead.
With optimistic rollups, I think like the technology is very simple to understand. You can look at the code and like. If you're familiar with how the EVM works, I think like that's sufficient to audit the system yourself.
Yeah, that makes a lot of sense. Auditing ZKPs is quite it's like, who do you even find? I mean, people obviously audit them, but it's kind of like, do the auditors have more experience than the developers? I don't know.
Yeah, we're sort of going down a formal verification route, but that is a very long and slow process. And so I think that is absolutely an issue. I was also curious, one of the things that's interesting is that obviously, ZKPs are much slower to prove the same code. If I want to execute something, it executes much more slowly inside a zero-knowledge proof system than it does in an optimistic sense. But the nice thing is that no one else has to double-check my work because it produces a proof, right? So I think there's going to end up being some trade-off there. It's very unclear to me how all of that's going to end up, but I do think that we'll see sort of that's, it is yet another dimension upon which people have to just make decisions. So
makes sense.
I'd like to challenge one thing, and that is, I don't think we should be saying that optimistic rollups be more used in the question of decentralization and what the risks are. And it's very easy to forget that we don't have EIP for it for live yet. It's very easy to forget that all of the data that we put on the L1 is super expensive and is basically being subsidized by VC right now, very centralized force. And the other thing being, like, L2Beat hasn't even started developing the green everything okay checkmark icon yet, because there's no fraud proofs to be submitted in a decentralized way in optimistic rollups, just as there's no ZK EVM running yet. So I think we are far, far away right now, and we actually do need to have those teams and those VC funds, you could argue, to actually have the manpower and the engineering to be working on this stuff and to have those big machines proving those ZKPs before we actually can ask the users to be paying for those fees. So that's a long way from our centralized state.
Interesting. So Jeremy, how have you found that decentralization and scalability interact with each other in, while designing systems or, yeah?
They have a lot of complex interactions, obviously. I mean, I think that that in some ways, zero-knowledge proofs do help with both of them because they allow you to only run computation once, which helps with scaling, and they also, I mean, really, actually, that same fact helps you with decentralization because you can now trust third parties to run code correctly. But I do think we've already sort of touched on it a little bit, but I think that the biggest issue is mostly in sequencing. I think that there are not, to my knowledge, really universally agreed on mechanisms for having a fully decentralized sequencing mechanism that also scales with the transaction rate in a really good way. I think some of that is soluble by reducing the sequencing requirements. Honestly, most things don't need to be fully sequenced. you can actually have lots of things running in parallel. I mean, pretty much all of the Web 2 world already does this everywhere. Good luck making a transaction across all of the elements in your S3 database. It's just not, you can't do it because it doesn't scale, and so people have given up on being able to do that. But I think that right now, that's a very different model from the model people are familiar with in the EVM. And so I think there's going to be, I think that the combination of scaling and decentralization is going to continue to run up against this roadblock until we figure out how to sort of make it more, friendly for, I mean, the developers are going to have to sort of understand how this works at some level.
Makes sense. Ujval?
Yeah, I don't have much to add. I think I agree with that. Like, I think as long as people are really, really interested in just like deploying on the EVM, I think you're going to have issues with trying to do things like, sharding execution without kind of.
And until then, the correlation approach is -1.
Brendan, anything to add?
I think just to, not much to add to Jeremy's point. I think that the strategies for scaling sequencing and for doing parallelization are really interesting. Like whether you build systems or adapt systems like the EVMs so that they can do parallelism better, or whether you aim for sort of different zones of computation, different shards that can sort of interoperate in a clever way. I think those are like really interesting challenges that we'll need to look at.
Yeah, I was watching Yuki from Fembushi's talk on MEV the other day, and just going through the difficulties of actually decentralizing sequencing. I was amazed at the amount of complexity that goes on there, and pretty much for every single part of that, you can use any number of like macroeconomic or ZK or potentially optimistic like mechanisms for securing every sub-bit of the system. It's like pretty mind-blowing. All right. So what technological advances, we'll go ahead and start with you, Ujval, do you think will impact scaling and decentralization the most in, say, the next 1 to 5 years?
I think like one of the biggest impact things is like all the work going on the data availability side for sure. I think that'll definitely help reduce like practical costs for sequencing quite a bit, both for like optimistic rules and potentially like validated rules, assuming they put transactions on chain. I would say that's one of them. Can't think of others off the top of my head. You can go ahead.
Yeah, I think in terms of the next couple of years, I actually don't, I feel like there's a lot of open questions about, for example, we've seen a lot of advancements over the last, 10 years of the underlying proof systems that zero-knowledge proofs use, and sort of new mathematical techniques that have allowed more and more efficient and practical ZKPs. I'm curious whether that will continue and whether that will continue to change the economics of zero-knowledge proofs. I think we're starting to see MPC and sort of homomorphic encryption slowly becoming more potentially practical. I think that there's a possibility of significant disruption in those fields if sort of the math ends up working out in a way that really matters. I think right now, the use of homomorphic encryption is not super plausible for general purpose compute, although it's useful in certain specific instances. But that may well change in the next couple of years, which will, I think, impact the way in which these technologies exist. I'm also sort of curious about the adoption of these technologies by the people outside of the existing sort of Web3 ecosystem, right? Especially with interesting models like where you're using zero-knowledge proofs to prove the correctness, but you are just purposefully having centralized sequencing, and whether those kinds of things will become sort of assumptions that people will be making.
Yeah, I think that, I guess for reducing cost insofar as that relates to scalability, I think newer provers will continue to see improvements there. And then, I think like more interesting strategies for ZK bridging, where you could do like atomic smart contract calls even across these like different zones of computation. I think something that's really interesting.
Yeah, I heard Plonky 3's done, right?
Yeah, I guess I'm the pragmatic guy in the room oftentimes, and I've been observing the ZKPs recently and noticed, okay, they've been around since 79 or so. No one really bothered for them for a few decades. And then the last couple of years have seen so much capital flow into this area that it's just hard to not be inclined to extrapolate this growth and basically assume that if so many so clever eyeballs paid so well are looking at these things and there's so much incentive to be gained, that it's very hard to imagine that we wouldn't have an even faster evolution of the proving systems, etc. Now, the other thing that I'm really looking forward to, and that's a bit maybe less pragmatic, is how do we deal with code bases of tens of thousands of lines where we can't really, or we don't really want to allow ourselves that many bugs, right? And so there's very interesting approaches on multi-prover systems or hybrid systems combining optimistic and ZKP properties. And so far, I think no one really had the time to do anything more than think about it and maybe read Vitalik's post. But I'm very hopeful that in the next couple of years, especially with the growing interest and funding in the space, that there will be actually people doing something a bit more applied with this respect.
Yeah, I've been honestly kind of surprised at how much the influx of capital has changed the rate of discovery and interest in this space to the point. It's like in my mind, you can't just put money into like a pile of people and then you get like good new mathematical results out. Like I don't think that always follows, but I guess it did at least. It seems to be at least for now. Yeah.
I actually anticipate just in terms of I think that if we look back in 5 or 10 years that we will see a much wider view in the industry that some of these advancements were deeply fundamental, right? The way that we look at public key cryptography, right? Which I think changed the way you could do trust interactions among parties, and it just revolutionized, the way that, all commerce is done through public key cryptography, huge amounts of impact in that. And I think that ZKP will be considered sort of a fundamental tool similar to that, not just in the blockchain space, but more widely.
Cool. Yeah, well, I think we have time for a couple audience questions. But while we're going through that, if the panelists can each think of what their absolute spiciest take is, short, then maybe we can close on a controversial note. Any questions? Yep.
I really love the debate on the kind of engineering trade-offs among scalability, correctness, and whatnot. I think, Jeremy, you touched on how do we grow the user base beyond kind of degens and whatever today, right? As much as we love DeFi, centralized institutions have product market fit with 99% of humanity. So, in your view, if we were to increase our market share to 10% of humanity, what should the engineering design look like? Because the average person has no idea of what Block 16 or what clock even means.
I think a lot of that is,
Did everyone hear the question? It's basically given how do you actually get the next N million people on board, given that DeFi and ZK are both pretty degenerate kinds of concepts?
I was going to say, to your point earlier, I think part of that is going to be figuring out how to do this sort of blue checkbox. How can people navigate what's actually pretty well studied, vetted, functional, versus what's just some random people on the internet who like cryptography and don't know what they're doing. And I think that there's also a big question around, when I started onboarding into the sort of crypto space, one of the things the way in which key management is done, the way in which users interact with the system, the way in which I feel like there's a lot of usability issues that are totally outside in some ways of ZKP, although some of them may be helped by it, ZK identity mechanisms and stuff provide a technical tool that can help you build these systems. But I feel like one of the big limits is just normal people don't know how to hold cryptographic keys in a safe way. These much more sort of I think a lot of the issues holding things back are not really about scalability. They're more just sort of general usability things that are actually complicated, interesting problems.
Yeah, I have to echo that. And this is a story like maybe people have heard me tell. I was at the StarCore sessions a couple of weeks ago, and I think I mean, maybe there are other ecosystems that have rolled out account abstraction to the extent that they have, but like Cartridge, which is a gaming company, they had this user experience that utilized the the account abstraction such that if you like scanned the code to get your POAP, it would actually create a new wallet, a hardware wallet basically on your iPhone using the trusted security module, and that would sync that private key to all of your devices, and it's still backed up behind your sort of the fairly decent cryptography in Apple products, and it's basically a completely seamless onboarding experience from taking a picture to actually having an NFT. And that was the moment where like the whole notion behind account abstraction in my mind like really clicked, and I was like, okay, this there's a lot of room for developers to make progress on making it easier for people to onboard. Yeah. Any other thoughts?
And not just people. Like if you go to a conference where you could buy your ticket with crypto or with fiat, and you will ask those degen devs how many of them actually used the crypto option? Not many.
All right. I guess we're jumping to spicy takes now. No. Any other questions?
Right. You touched the trade-offs about scalability and decentralization. So they were like, and you also discussed like general engineering. So engineering, there is a paradigm shift with databases from SQL to NoSQL. There was this term of eventual consistency, those trade-offs. So like, are there any similar trade-offs without hitting the trust, right? Just similar to this shift.
Interesting. The question, so people in here is like between sort of SQL, NoSQL, and global, eventual, consistent databases. You've seen like the programming paradigm change a lot, and it's people have made these trade-offs specifically for scalability. And are there parallels in the space?
I mean, I think fundamentally there are going to have to be changes to the common programming modalities if people are really going to get the scale that they want. If you really want, millions of transactions a second, I think that the notion that those are all going to be globally sequenced and all able to see all of the state in the world and all the data availability for that's just going to work is just not. I mean, if without decentralization and proven correctness and all these other things, the Web 2 people can't manage to get a consistent global database that supports that transaction rate. Certainly, you're not going to get it with all these other things. So I think that. And I think that is going to be, there's all kinds of ways of shifting that programming model, this notion of having multiple sort of, atomic regions that each look like their own sort of separate blockchains and doing, making the process of moving between them more tricky, but still something the programmer has to manage, versus mechanisms of having sort of the models of eventual consistency that the Web 2 world has gotten used to. I think that the answer is, I think absolutely there will be required changes that developers will have to understand in order to actually achieve these scaling goals. I don't know what they look like yet, but I think.
Yeah, I would maybe distinguish between two models. Like when we talk about scalability, it's often so vague that it doesn't have a lot of meaning. But fundamentally we know how to scale lots of transactions that don't depend on the same shared state. But I think that the shared state case for crypto is more interesting because we have Uniswap pools and ideally we'd like to be able to support millions of TPS that touch the same state. And so I think for that case we need to accept latency. So we can look at batching trades and then but then there's this sort of question of capital efficiency because there's this step in between me declaring my intent to trade and that intent being batched in sort of an action that's atomically applied to that pool. And so I think that there are certainly a lot of trade-offs.
Yeah, very interesting. It's maybe the Renegade, was it the, Jeremy, you were talking this Renegade protocol or something with dark pools is dark clobs that are batched. Maybe they solve that problem. Who knows?
I think it's great though to hear about eventual consistency. It feels like we are having way too few people who did something other than blockchains, even though there's so much to be learned from pre-blockchain era. So I think there is definitely lessons to take over.
Makes sense. Ujval?
No, I don't have anything to add.
All right. Well, I guess we'll just go to people's takes here, and I'll just start with mine, and that's that. Along those lines, I hear you can now buy atomic clocks for $3,000. So my hot take is that spanner and time-oriented databases are going to make a big comeback in Web3. Yeah.
I guess my spicy take is simply that we tend to be so fascinated and enthusiastic about ZKPs that we just want to be doing the hard stuff for the hard stuff's sake. And I think that's bad. That's not just not good, it's actually negative and destructive. And so we need to be asking ourselves what it actually is that makes sense overall and not that it's just cool.
I'm not sure I have a good spicy take. I think I think Polygon. At Polygon, we're trying to reduce the level of spiciness, especially on Twitter. maybe that's just me. Yeah, I mean, so I'll give like a very vanilla take. I think that there will.
Was
be,
that your hot take?
Yeah, don't tell Sandeep. Yeah, I think that there are like a lot of like avenues that we are exploring and should be exploring, like ZKVM, ZKVM, and I think that there's like a lot of like value and like it's a big green field, and so I think it's good that we're doing that.
Yeah. Vanilla. I don't know if it's a spicy take exactly, but I kind of feel like the actual mass adoption of these technologies that we're working on is significantly farther than people think it is, but I also think that they are going to they're going to be just almost universal at some point. Like I think like when we look back, it will be like, like this it reminds me in some ways of this sort of .com bubble and then the crash. And everyone was like, oh, those .coms are pointless. And then, many years later, suddenly everything is like on the internet. And I think that we're sort of in the like, it's not going to be good for a while. But I do think that long term something's going to happen, yes.
Yeah, I'd say I think getting things like formal guarantees for these systems is going to take like decades potentially, and until that happens, I think like one of these ZK rollups that exist today is probably going to have like some soundness bug, just going to get exploited. Just as like all these bridges are constantly getting exploited, I think like at least like one of these systems is probably going to.
Yeah, that's going to be I agree, but it is kind of spicy because maybe it's hard to find bugs in these systems especially from the outside. So.
Yeah, once there are like enough people who understand ZK proving systems, they'll try to look into them.
Once there's enough value locked to make
yes,
it.
exactly.
or like maybe the other alternative is like the training wheels never come off.
Yeah.
Because we just never get the sort of confidence which is kind of dark.
That would be kind of dark. 10 years later, we're still like trying to audit our ZKP systems. Yeah, that's not gonna happen. Anyway, let's give a round of applause for our panelists here.
And the moderator.